Start our lesson today out of our book 7.2, and our goal is to learn how to factor polynomials by pulling out or undistributing the GCF. Now, sometimes there is a GCF and sometimes the GCF is a 1. We don't pull 1s out, okay? I do want to go ahead and qualify that ahead of time. If your GCF is a 1, then the best you can do is it's a prime polynomial, and you're not going to be able to factor it, okay? So let's start with letter A. We're looking at 4x squared minus 3x, and first thing we have to do is identify the GCF. So as you're looking at it, first study the numbers. Let's look at 4 and then the number 3, okay? So what is the GCF of 4 and 3? That's the biggest number that's a factor of both 4 and 3. Now we're going to try and challenge you to do these mentally. If you need to write it out to the side, I'll do it for the first one just to refresh your memory, okay? If we list all the factors of 4, that would be 1, 2, and 4. Okay, remember 1 times 4 is 4, 2 times 2 is 4. Those are your only 3 factors, 1, 2, and 4. 3 only has a factor of 1 and 3. What number do you see up there that's common? And if you are seeing and circling the 1, you are absolutely correct. Okay, so we would pull out a 1, but like I said, we don't usually pull out a 1. Okay, that's just a supreme waste of time. Let's see here. Let's focus on the x's because I think we are going to find a GCF with our x's. Okay, remember what I told you in 7.1 when we went over that. If you have the same variable in both terms, and we do, we have x squared and we have x, then you always choose the one with the lower exponent. Always, always, always. That's your GCF. We have at least one x in each term. Okay? So that's our GCF. So we're going to pull out an x. This is what we call factoring. We're going to pull out or factor out a common number or a common variable in each of these terms. Okay? So here's how I do it. Basically, there's a couple ways you could do it. Here's what I do. I ask myself, x times what, and the what's going to be written there on that line, x times what will give me 4x squared. Now remember, I just pulled out an x. And so that would be 4x. X times 4x is 4x squared. Okay, drop down your minus sign. X times what is 3x? Yes, x times 3 is 3x. So what we just did was we factored out an x, and so that's what you do when you pull out a GCF. You find the GCF of both terms, and when you pull it out, you have to tell in the parentheses what's left behind. What's left behind? You can't just write x down. There's still stuff there, and we have to show what remains after you pull it out. Here's another way I've done it. If you're like, I know I'm pulling out an x, then you can divide both terms by x. Okay? Now remember, 4 is unaffected. What's going to change is right here. X is going to cancel out with one of those x's. There's your 4x, and we write that right there. Okay? And then 3x over x, the x's canceled, leaving you a 3, and that's where I write that. Okay? That's just another way to look at it. You can look at it as though I'm dividing each of those terms by that GCF, by x, or you could do it like I showed you. I'm going to try and emulate it a couple of ways so you can see it and start to feel and discern a pattern. That's what I'm hoping to do for you. Okay? Now I'm going to erase just a little bit. I have a little bit of extra information here that I don't want. There we go, that's fine. And let's move over here to the right to B. All right, here are my choices. I actually have a trinomial, okay? So I am going to pull out a GCF, but I'm going to have 3 terms left over in this trinomial, okay? I'm going to have 3 terms. So start with a number, 10, 20, and 5. 10, 20, and 5. What's the GCF? What's the biggest number that's a factor of all three of those numbers? Good job. If you said 5, you're exactly right. 5 times 2 is 10. 5 times 4 is 20. 5 times 1 is 5. So you got it. You nailed it. A little trick that I do is when I look at the numbers, I look at the smallest number, which is 5. If it can go into both 20 and 10, that's my GCF. That's how I normally roll. It's fast strategy for me, and it works. Okay, now let's look at our variable. I have y cubed, y squared, and y. Remember what I told you. When you're looking for GCF, always choose the variable with the lowest exponent, and so that would be y. Okay, so there's your GCF. Now what we want to do is we want to figure out what's left behind if I pull out or undistribute or divide each term by 5y. What's left? Okay, now if you need to take each term and literally put it over 5y and see what you can come up with. What's 10 divided by 5? 2. What's y cubed divided by y to the first? Y squared. Yep, you can do it that way. It's not a bad way to do it at all, if that makes sense to you. How I normally do it is I'll ask myself, 5y times what is 20y squared? So let's start with the numbers. 5 times what is 20? 4. Y times what is y squared? Y. And I can get there the same way. You know, you can divide it or you can do it like I just showed you. 5y times what is 5y? 1. So this is your factored answer. Okay, you pulled out your GCF. Here's the GCF right here, 5y. And then in parentheses, this is what's left behind when you remove or undistribute or divide out that GCF. 2y squared plus 4y minus 1 should be in parentheses. Okay, that's what you do with your quantities. You put them in parentheses. All right, let's look at letter C. Hopefully this is starting to make a little bit better sense. If it doesn't, I'll keep doing a couple and, you know, we'll of course hammer this in class. All right, we're looking for the GCF of negative 12x and minus 8x squared. So 8 doesn't go into 12, so I can't use my little trick here. So I do need to think of the biggest number that is a factor of both 12, negative 12, and negative 8. A couple ways you could factor this out. You could say, hey, I'm going to factor out a 4 because I know 4 times 3 is 12 and 4 times 2 is 8. You would be correct. That would be a good choice. And then when you look at your variables, you have x and x squared. Choose the lower of the two. Choose the x. Okay? Now let's put in parentheses whatever is left behind. So 4 times what is negative 12? You're right if you said negative 3. 4 times what is negative 8? Negative 2. And then x times x is x squared. Now I skipped the x's in that first one because x times 1 is x and the negative 12x. So my x's were already accounted for. I didn't have anything, any extra ones that I had to put there. Now, here's another way you could do it. Sometimes when you have a leading negative number, you can go, hey, I want to pull out a negative GCF. This will come up later in chapter 7 as we get deeper and deeper and deeper into this chapter. This will come up and this will become an issue. And you need to know that both of these answers mean the same thing. So instead of pulling out a positive 4, let's pull out a negative 4x. All that does is it changes the signs that are inside the parentheses. When you go ahead and pull out a negative 4, this is what happens. Negative 4 times what is negative 12? Positive 3. X times 1 is x, so I don't have to worry about x's there. Negative 4 times what is negative 8? positive 2, x times x is x squared. And so the basic difference here between these two is if you pull out a positive number and both numbers were originally negative, then the inside of your quantity will remain negative. But if you get aggressive, pull out that negative number like we did here, then what's left in the quantity will be positive numbers. This is very, very confusing, but both of these answers are the same thing. They are equally correct, and they mean the same exact thing. Okay? I just pulled out a positive 4 at the top and a negative 4 on the second line. It is the same answer though, technically. Doesn't look the same, but they are. Okay? Let's look at letter D. We're looking to see if there's a common factor, GCF, of 5x squared and 7. Well, I can already tell you the greatest common factor of 5 and 7, they are both prime. The greatest common factor is 1. Okay? And there's only x's in the first term, not in the second term. This does not have a GCF. There is no GCF other than 1. And so we don't factor out a 1. Okay, that would just be a waste of time. If you pulled a 1 out, this is what it would look like. 1 times what is 5x squared? 5x squared. 1 times what is 7? 7. Do you see, you didn't change anything. The 1 changed nothing. You didn't really pull anything out. 1 times any number is that number. So we don't generally do that. We just say it's not factorable and this is your final answer right here. Okay, so just want to make sure I am clear with you. If your GCF is the number 1, exactly the number 1 and only the number 1, no variables, no nothing else, then it's not factorable. You just leave it alone. It's prime. It's what we consider and call prime, okay? This is a prime binomial if the only GCF is a 1, okay? Now E, I'll go ahead and do E just because I think we're starting to get it and want to keep helping you with the process, okay? So E, we're looking for the GCF of 5b and 9b cubed. Now 5 and 9, GCF of 5 and 9, 1, okay? That number, very simple. But we do have a GCF here with our b's. We need to pull out a b, okay? We have at least one b in both of those terms. B times what is 5b? 5. B times 5 is 5b, okay? Drop down your plus sign. B times what is 9b cubed? 9b squared. Why? Because b times b squared is b cubed. We didn't change the 9. What we were doing was change the b's because we pulled the b out, okay? And that's as good as it gets right here. That's your answer. That's your factored answer when you pull out a GCF, okay? Letter F, I would go ahead and change that to 64, okay? Go ahead and make that a little bit easier. Now we are looking for GCF for 9 and 64. I don't personally see one, is my advice for you. I don't see a common factor, greatest common factor for those two numbers. 9 doesn't go into 64, and it looks like the GCF is a 1. So this is another one where we have no GCF other than 1. And so I would consider this prime. Now I can't pull out a GCF because it has a GCF of 1. Okay? So I just leave this as my answer right here. Whoop, what happened? Here we go. This is what I would do. Just leave that one as my GCF. Letter G, it starts with a negative number, and I will just tell you what I normally do. If my first coefficient is negative, I pull out a negative number. That is what I do normally. It's not wrong if you don't, but that's what I normally do. So as I look at the numbers, negative 18 and negative 7, 7 is not a factor of 18. So I can't pull out a negative 7, and it's prime. The only other number I could pull out is a negative 1. And then the y's, we're going to pull out y squared. Okay? So negative 1 y squared times what is negative 18 y cubed? Well, negative 1 times positive 18 is negative 18. And y squared times y is y cubed. Negative 1 y squared times what is negative 7y squared? We'll start with the numbers. Negative 1 times positive 7 is negative 7. Y squared times 1 is y squared. So I don't need any y's. I have exactly what I need. And there's your factored form right there. That's not the only way to do that particular answer. You could have just pulled out a y squared and been left with negative 18y minus 7. You could have done it like that. That's equally correct. No problem there at all. Just, I normally, if I see a leading coefficient is negative, I normally pull out a negative number. That's just how I roll. Okay? Now I've done a number of these. This is not an easy concept, but I am going to leave this one for extra credit. So if you think, and you're up to the task, why don't you try letter H, see what you can do. Find the GCF, pull it out, and show me what remains in a set of parentheses. And bring your questions to class. We'll be hammering this concept in class tomorrow. Thanks for listening.